Level testing, level, hello, you're good? All right. All right, so I've been sitting here reading about how what I'm doing is maybe not a good idea, but I'm gonna present it anyway because you guys came down here to check it out. So this is the GitHub repository that has all of my stuff, and if you're into Perl at all, you can run these scripts, but I'll run them for you. So if you're not into Perl, that's fine. So the problem that I'm trying to solve is one that I've been doing computer stuff for about 20 years. And a lot of times you'll have relational databases that have structures where someone said, oh, hey, we're going to organize all of our employees. So we'll have a table called employees, and then those employees go into departments, and departments go into divisions, and then divisions go into regions, and then the CTO reorgs the whole thing, and suddenly they're all, cross-divisional, whatever, and everybody's like reorganizing the schema constantly. And whenever the schema reorganizes, you have to reorganize all your source code. It can be quite a pain. And so genius people like me say things like, oh, hey, wouldn't it be nice if this was just in some kind of arbitrary nested tree hierarchy, right? So that I don't have to know what the VP thinks the things that the departments go into are called necessarily, that it can just be this arbitrary tree. And so then you go in there and you go, oh, well, what I'll do is I'll just have a row for every entity, and then I'll just have like a parent ID column. So like with the parent ID, I'll just point up, and then everything will be fine. And then you mess around with that for a few hours, and then you realize that it's hard to figure out if you're 15 layers deep on a tree, like what the relatives are, like what are your siblings, and then what's your uncle, like if you have to go up the tree, but then sideways, how does that work, et cetera. Turns out that lots of folks have dealt with this problem since probably the 70s, 60s or 70s. And I stumbled into one such solution in my language of choice, which happens to be Perl, where this nested set was implemented as a plugin to the ORM, the object relational model that we use called DBIX class. And it's all just implemented here. And I'm like, oh, look at that. I can grab all my nodes and parents and children and descendants and ancestors. And when I want to attach things, oops, I can see all my left siblings and rightmost siblings. And then I can attach my rightmost child, leftmost child, right siblings, left siblings. And I don't have to write any of this source code. That's pretty cool. So I was going to check that out. And how that works is, at the top of your table, whatever schema you're creating, you can just give it these magical columns, and it'll do all the work for you. And I'm like, oh, that's pretty neat. And this is called a nested set model. And Wikipedia has all kinds of information about nested sets versus other types of models. And there's a lot of advantages and disadvantages to organizing your hierarchical data in a relational database in various manners, right? So sometimes what you really, really care about is being able to query extremely quickly. And sometimes what you care about is being able to manipulate your tree really, really quickly. And these two things are kind of a trade-off situation. Depending on how deep your hierarchy is and how wide your hierarchy is, your speed, your performance is going to vary depending on how you implement, right? But if we look at this just from Wikipedia, if we look at a possible taxonomy like this, or hierarchy or tree, this is how nested set works, is that it defines the edges of all these different sets and then keeps track of them for you in the software. So what I was reading is about recursive Postgres and modern Postgres engines. There's recursive querying things, which I've seen, and this is talking about different agency lists versus path enumeration versus closure table model versus nested set model, and the performance metrics across millions of rows and millions of hierarchy, whatever. All right, anyway, so to get back to what I actually implemented, just to check out how easy this is, you're gonna be amazed. What does that mean? I know that. I've been staring at it the whole time. So how this works, if you want to just implement it out of the box as it exists, is we start with just our schema table. And these things at the top are just the magic that the library wants to do all of its stuff. And then at the bottom of the table, we can put whatever columns we want, right? So you can have 50 columns in here if you're tracking all kinds of column information about the database, yeah? So in Perl, there's a library called DBIX class schema loader. And if we say things like this, what we can do is we can point at the SQLite database that we created, and we can say, hey, blow out all the source code required to do all of the ORM operations on the entire database, which is pretty slick. And so it'll generate an entire result table as a single table. And in the bottom of the result, it figured out from the metadata of the database all of the add columns, et cetera, and everybody uses ORMs nowadays, right? If you don't, just stop me. But down at the bottom of, because we want this taxonomy table, we called it, to be a tree nested set, we just copy and paste this from the documentation. And now the ORM knows that this specific table has all of those 50 subroutines also available on it. And then we can use the thing. So what we're doing at the top is we're just connecting to our SQLite database. And then for our first little demo, we're going to nuke all the data in the table. You might want to not leave that in production. And so for demo 1, we're going to create a new row. This is the syntax for that in DBIX class. So we're just going to create a row that says J, and we're going to create another one that says Ruby and Open Source Meetup as the name. And then we're going to attach as the rightmost child the meetup to the J object. Yeah. So you just call methods on the objects. Did that make sense? Any questions about that before I go do that? Live demo. Nope. Ooh, a frog. Nice. All right. Oh, so let's see. So here's that refresh schema that we did earlier. We've just got a SQL file that just says create our tables. That is what refreshed all of our schema. So usually you'd have lots and lots of tables and it would do lots and lots of work for you, but it's pretty quick right now. So our little demo was this little program called SeedDB. And then there's another one called Taxonomies Viewer. The Taxonomies Viewer connects to the database. It grabs all the roots. In our case, there's only one root, yeah? And it says, while I can pull the next root out, then print children with an offset of 2. And then print children is recursive, and it just bumps +2 the offset, so it can be as deep as it wants to be. Yeah? Is everybody asleep? So when I run on just that 2-line demo where we just created 2 rows and we attached one as a child, run the taxonomies viewer on that, then I just end up with this tree, right? Simple. So we move on to demo number 2. So we're going to loop in some additional hierarchy here. So Omaha, Nebraska, USA, North America, Earth, etc. And in that loop, we're just going to attach as the rightmost child down the tree. And then run our taxonomy viewer. And we can see that the loop zipped up all of that information, and now it's all nested. Yeah? But that's not terribly interesting because you might think that I'm cheating. So I'm going to add another down here in demo 3. I'm going to add another country, USA, and I'm going to add another country, Canada. Then I'm going to add another country, Zambia, with a central and southern province, and there's a city there. And I want to attach the children in the way that makes sense given that Choma City is in the southern province of Zambia. Does that make sense? So the nested set model keeps, each set is ordered. So the leftmost, rightmost, et cetera, you can tell it exactly what order you want them to be in. And maybe your hierarchies don't care about that, maybe they do. But we've now shoved Canada in front of USA and Zambia below it, right? And the city and the province in Zambia, et cetera. Yeah? Yeah, and that's it. So because it's so little code to do the roughouts, I've been using this at my day job where we're trying to map a lot of years of history and a lot of database tables into a simplified taxonomy structure. And so we have millions of rows and about 12 levels max right now. But across all of these different data mappings, trying to come up with a simplified API where everything lives in a single consolidated universe of taxonomy is the idea. So I need to do a bunch of benchmarking of this specific implementation versus other implementations of different sets and different trees and hierarchies. But the important thing, I think, is that if your ORM already supports whatever set fits your needs in terms of how deep your hierarchies are, how wide they are, pick the one that the computer science folks say and then prove it by benchmarking them all. If you can just switch back and forth on how the storage mechanism works, all of your data mapping can all be the same, right? The method names might change for each of the plugin libraries that you're using, but you can test and see, okay, well, which of these nested set things, or nested set versus all these other things, is actually more performant given how much data that I have, or hey, I'm going to have a lot more data in the future, or whatever your growth expectations are. So don't just throw a parent ID in a table unless you're using Postgres with recursive, which is what this guy said is more performant anyway. So I have to do more reading on that. That's it.